In this video, we will talk about NFC or Near Field Communication, its usage, working, and utility. We will talk about its concept, history, role of EM waves, implementation in mobile phones, and some other related technologies.
NFC is a radio standard used to transfer small amounts of data over a limited range. This technology uses magnetic induction between two coils fitted in the devices. A reader emits a small electric current which creates a magnetic field that in turn bridges the physical space between the devices, forming an air core transformer, which is the reason for its low range as the magnetic coupling between the two cores drops significantly after a few centimeters of separation. The field is received by a similar coil in the client device where it is turned back into electrical impulses to communicate data. NFC is an evolved version of RFID technology which allows communication with passive, unpowered electronic tags. Unlike Bluetooth, it does not require the need to pair devices first, thus making the setup process simple and quick. But the lack of pairing means it is less secure than the other technologies and susceptible to security breaches. The speeds are not great either, thus making it unusable for transferring large amounts of data.
We can find NFC enabled devices anywhere nowadays, be it your smartphone, credit card, or those inexpensive NFC tags. But the smartphone is different from the other two in an important way. That is, it has a power source, while the others don't. This brings us to the two modes of communication using NFC, which are active and passive. In the passive mode, the initiating device communicates with the other by sending a carrier field, and the other device responds by modulating that field. The operating power for that comes from the wave generated by the first device. In the active mode, both devices communicate by alternately generating their own fields, with the device powered off while waiting for or receiving data. And when none of the devices have a power source, there is no transfer of any information.
The operating frequency of NFC is 13.56 MHz on ISO IEC 18000-3 air interface and has a typical bandwidth of 7 kHz, but the full spectral envelope may be as wide as 1.8 MHz when using ASK modulation. Supported data rates are 106, 212 or 424 kilobit per second, as the bitrate 848 kilobit per second is not compliant with the standard ISO IEC 10892 standard. The use of NFC in smartphones has become very popular over the last few years. Some of the popular uses include payments with your smartphone acting as a digital wallet, for example, Apple Pay or Android Pay, or transferring small amounts of data like contacts or photos from one smartphone to other. NFC is used more commonly as an intermediate in data transferring for bootstrapping more capable wireless connections like Wi-Fi Direct or Bluetooth. This can be seen in services like Android Beam.
Another technology that works on a similar electromagnetic waves principle as of NFC is wireless charging, which uses electromagnetic waves to transfer energy between two devices, unlike NFC, which uses the EM waves for the transfer of data. This is where we conclude our video. Thank you for watching.
Your time is up, my time is now. You can't see me, my time is now. It's the franchise where I'm shining now. You can't see me, my time is now. In case you forgot or fell off, I'm still hot, knock your shell off. My money stacked fat, plus I can't turn the swell off. The franchise doing big business, I live this, it's automatic, I win this. So you hear those horns, you finish. A soldier, and I stay under you fighting. Plus I'm storming on you chumps like I'm thunder and lightning. Ain't no way you breaking me, kid, I'm harder than nails. Plus I keep it on lock like I'm part of the jail. I'm slaughtering stale competition, I got the whole